Hello all, myself Dr. M. Laxmidevi, Associate Professor in the Department of CACDS at Institute of Aeronautical Engineering. In this video lecture, we'll discuss the questions based on user-defined functions. So we'll try to solve some programs. We'll try to write some programs based on user-defined functions. So these are the different functions. The first one is write a C program that uses functions to convert binary number to decimal number. So we know that, so let us see a brief discussion about, let us revise briefly the concept of functions. So what is function? So function in the sense it means user-defined functions. So user-defined functions are the functions which are defined by the user. So according to the requirements of the user, he or she can define the function. So we have seen, so in my previous video lecture, you can go through the video lecture titled user-defined functions. So there we have seen, we have discussed in detail about the different concepts of user-defined functions, the need of user-defined functions, as well as the advantages and disadvantages of user-defined functions, along with some sample programs. So here we will see. So need of user-defined functions is to increase for modularity purpose and also for code reusability. So the main user function is, or the main advantage of user-defined function is code reusability. So with code that means the same set of statements which are defined in the function can be reused again and again. So that is the main purpose of user-defined functions. So here let us write a C program which uses functions to convert binary number to decimal number. So we know that how to convert. So binary number has a base 2, whereas decimal number has a base 10. So we know that if this is the binary number, its decimal form is, we can convert this binary number to decimal number. So in this way, so 0 into 2 power 0 plus 1 into 2 power 1. So the decimal number corresponding decimal equivalent for this binary number is 2 power 0 is 1, 0 plus 2, which is equal to 2. So in this way, so let us write the program for this. So here we have defined the user-defined function. So this is the user-defined function. So any user-defined function, mainly it has 3 elements. So first one is function definition. First one function definition, then function call, and then function prototype. Function prototype. So after this statement, after this statement we have directly defined the function. So therefore no need to use this function prototype. So directly we have written the function definition. Next, in the main function we need to call the function. So this is a function call. So here let us see the main function. So here we have declared a integer variable named binary number. So this is a binary number. So it is a variable. Binary number is a variable which stores the binary value which is entered by the user. So it is stored at this particular address. So there is some, for each particular variable we have the address. So scanf requires the address of that particular variable in order to store the variable value at that particular address. Next, this is how. So since this function, so this is the function call. Function call is done in this way. First, we need to write the name of the function, then followed by the arguments. Since the function requires only one argument, so therefore we have passed only one argument, that is a binary number. And since the return type of this function is integer, so therefore we have declared one integer variable decimal number to store the value which is returned by this function. Now let us, whenever the compiler sees this statement function call, so control is automatically transferred here. So hereafter the function statements are executed which are written in the function definition. So in this function definition we have local variable decimal number which is assigned a value 0, and then a variable integer variable I which is assigned a value 0, and then one more variable remainder. So then by using while loop, so we have implemented the logic. So logic here is very simple here. So we know that we enter some binary number. And then in order, what we are doing here is we need to extract each digit from this binary number and just multiply it by 2 power. So in iteration 1, so starting from this side, that means right hand side to left side. So we approach the last digit. So first we approach the last digit. This 0 into 2 power 0 we multiply, and then whatever answer we get, so that is given, that is assigned to some variable, and then after that this value in the next iteration, this digit is extracted from the number, and then so we need to extract each digit from this particular number and then multiply it by 2 power 0 in the first iteration. In the next iteration, 1 is multiplied by 2 power 1, 0 multiplied by 2 power 2, and then this 1 multiplied by 2 power 3. So in this way, if you add all these values, you will get the value as, suppose this is a binary number you enter, then its corresponding decimal equivalent is, this is 2 power 0. So these values will get vanished. So only value which is available here is this and this one. So these two will be added. 2 power 1 is 2 plus 2 cube is 8. So which is equal to 10. So corresponding, so this is base to corresponding value is this. So in this way, let us see the logic here. So while binary number is not equal to 0, that means suppose we enter 1010 is the number. So this is not equal to 0, that means this is true. So this condition is true means it will execute these statements which are there in the user defined function. So here after that we get the remainder for this number. So remainder for this number is 0 in the first iteration. So remainder is 0, and then the binary number, we get the next binary number is assigned a value. Binary number is equal to binary divided by 10. That means the quotient. So in the first iteration, remainder is 0 and binary number is 101. So decimal number is equal to, decimal number is remainder. So remainder into, so what is the meaning of this statement is 1 is shifted to the left by 0 times. So this implies 1 shifted to the left by 0 times. So initially I is assigned a value 0. And in each iteration, what we do is we increment the value of I. So initially, 1 is shifted to the left by 0 times. That means 1 left shifted to the right 0 times. This implies it is equal to 2 power 0. 1 into 2 power 0. 2 power 0 is 1. So 1 into 1, which is equal to 1. So similarly, so this is equal to 1. But we have value 0 here. Remainder is 0. So 0 into 1 is 0. So therefore we get the decimal value as 0 in the first iteration. Next in the second iteration, next in iteration 2, in the second iteration, the new binary number is this. Again it is checked for the condition 101 is not equal to 0. So this condition is true. So therefore these statements are executed. Again the next digit is extracted. So remainder is 1 now, and the new binary number is 10. So 101 divided by 10. So when you divide this, it is 10 ones. It is 10. So this is equal to 10. So new binary number is equal to 10. So after that, the decimal number is equal to remainder. Remainder is 1. So 1 into, when you left shift this, so 1 left shift by 1. So it is equal to, so this is equal to 2 power 1. So 1 into 2 power 1 is equal to 2 power 1. So here you get we get the value as 2. So in this way, these steps will go on repeating. So this while loop will go on repeating till the binary number is not equal to 0. And finally, we get the value as 10. So in this way, so if you execute this program, and at the end, this printf statement will print the corresponding decimal equivalent. So percentage $d is the format specified to print the corresponding decimal number. So if you enter the binary, if you execute this program and enter the binary number as 1010, then you will get the output as decimal equivalent is 10. So next program is, this is a other program we are going to see by using user defined functions. So here we are going to write a function to convert decimal number to binary number. So we know similarly you can do vice versa also. So suppose this is the decimal number. In order to convert it to binary, so its binary equivalent is 1010. So we have to continuously divide it by 2. So remainder is 0 here. And then 2 2s are 4, 1. So 2 1s are 2, 0. 2 zeros are 0, 1. So in this way 1 0 1 0. So this is the binary equivalent for this decimal number 10. Now let us see how to do this with the help of program. So here we are declaring one integer variable that is named decimal number, and then after that we need to store the value of decimal number at this particular address. So then we are calling the function decimal to binary. So we are passing only one argument. So you can see here, so return type is void here. This is the name of the function, and this is the type of the parameter or argument you need to pass from the main function. And then here we have declared one array. So binary array of size 30, one integer variable I is equal to 0. So here what we are doing here is, so we are checking the decimal number. Suppose we pass a value 10 from the main function. Suppose the decimal number which the user has entered is 10. So this value is passed here. So your decimal number is equal to 10. So 10 is greater than 0. So this condition is true here. So when this condition is true, so what we do is we get the remainder of this number, divide this number by 2 and then get the remainder. So when 2 you divide by, 10 is divided by 2, 0 is the remainder. So that 0 is assigned. We have declared one array, binary array of I. Initially I is equal to 0 here. Binary array of I, that means 0. So this is equal to 0. Initially it is 0. Then again decimal number is equal to, you need to divide the number by 2 and get the quotient here. So the new decimal number is 5 now. So when you divide 10 by 2, the quotient is 5. So that is assigned to decimal number. I value is incremented by 1. So in the first iteration, I is equal to 1 now. So I plus this implies I is equal to 1 now. Then again it is checked. So 5 is greater than, in the second iteration, this condition is checked. 5 is greater than 0. So this is true. So therefore, in the next binary array of 1. So binary array of 1 is equal to, so again this number is divided by 2. 2 2s are 4. 1 is the remainder. So that remainder is stored in this array. So so you have a binary array. You have an array. So at the 0th place you have 0. At the first place you have 1, 0, 1. And then I value is incremented by 1. So now I is equal to 2. So now what is the decimal number? Whatever you get the quotient. So that is the decimal number. Now the quotient is 2 here. Now the new decimal number is equal to 2. So this condition is satisfied. So therefore when you divide 2 by 2, the remainder is 0. So here you get 0 here. Then after that is stored in this array at the second place at this index, and then again the new value. So 2 divided by 2, the quotient is 1. So new number is 1 now. So 1 greater than 0, that is true. So therefore again this is divided, the remainder is 0 now. So you get 1 here. So in this way, so these statements, the statements in the while loop are executed. So in the array, binary array, you have 0 1 0 1. So at this point I value is equal to 4 now. So at this point I is equal to 4. So when you need to display the elements, so when you are displaying this binary equivalent for this decimal number, you need to print the value from the last index. So that is 1 0 1 0. So therefore for that we are using a for loop. So for j is equal to I minus 1. So why? Because I is equal to 4 now. So therefore 4 minus 1 is 3. So at the third place, so j greater than or equal to 0. So this loop will repeat 4 times, and here it will print the corresponding the value which is there in this array. So answer which we get. So when we execute this program, so if we enter a decimal number 56, so the binary equivalent for this corresponding decimal number is 111 Next program is to write a program that uses both recursive and non-recursive functions to find the sum of n natural numbers. So we have also discussed the concept of recursion. So what does recursion means? Recursive functions are nothing but the functions which call itself. So it is also like functions only. So recursive function is nothing but a function which calls itself. So by using that approach, by using recursive approach as well as non-recursive approach, we are going to find out the sum of n natural numbers. So sum of n, suppose the user is entering 5. So n value is equal to 5. So sum should be 1 plus 2 plus 3 plus 4 plus 5. So by using both recursive and non-recursive approach, so whatever approach we use, the answer should be the same. So in the main function, we have declared a variable, integer variable n. That value is stored in at this particular address. So then after that, we are calling the non-recursive function. The name of the function is sum non-recursive. We are passing the value of n. So at this point of time, non-recursive means this is a function definition for non-recursive approach. So for non-recursive approach, we are using a for loop here. So for I is equal to 0. So initially I value is initialized to 1 and then I is less than or equal to n. Suppose n is equal to 5 here. So it will be 5 and then after that I plus plus. So for the first iteration I is equal to 1, sum is equal to sum plus 1 which is equal to 1. The next iteration when I is equal to 2, sum is equal to sum plus I. That means 1 plus 2 which is equal to 3. So in this way this loop will go on continuing till I is equal to 3, 4 and 5. So at the end we will get the sum. So that sum value is returned by this function. So here you can see that it is the return type of this function is integer type. So therefore here we have to return an integer value. So its value that is stored in the variable sum. So after this the function call is again returned here. The control is again transferred here. So non-recursive sum. So in this we get the value which is returned by this function, that is sum. Then after that in the next statement we are calling this function sum recursive. So here it uses recursive function approach. So we are passing the same parameter n and then here this is the definition of the recursive approach. So in recursive functions, so we need to satisfy the condition that it should have a base condition, base or terminating condition you can say, and then the other one is recursive function. So this is a base condition. When n value is equal to 0, it will return a value 0. So else it will go on calling the same function again and again. Now let us see if we pass a value 5 here. So n is equal to 5. So therefore, so whenever there is a recursive approach in recursive function, so activation records are maintained on the stack and activation records are maintained on the stack. So here suppose we pass a value 5 here. So it will return. So sum of recursive 5 is equal to, it will be equal to 5 plus, again this will call 4. Then after that sum of 4 will be equal to 4 plus sum of 3. It will call this function itself. Then sum of 3 is equal to 3 plus sum of 2. And then sum of 2 will be equal to 2 plus sum of 1. And then 1, sum of 1 will be equal to 1 plus sum of 0. So when it is 0, when n value is equal to 0, it will return 0 only. So corresponding value is 0. And then 1 plus 0 is 1. So this value is returned to the previous function. So that means this one. So this will be equal to now 2 plus 1, 3. 2 plus 1 which is equal to 3. And this value is returned here. So 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. So in this way, this function will be executed. So it will return that value. N value is 15 here. So here the return type is integer. So the value which is obtained from that function, which is returned by this function, so it is allocated to this variable recursive sum. So when we execute this function, when we execute this program and enter, it will prompt the user to enter a positive integer n. Suppose we enter the value 5. So first non-recursive function will be called and then the answer will be printed. And then in the second case, in this statement, the recursive function is called and then the value is printed. That is, in both the cases, we get the same answer, that is 15. Next program is to write a C program that uses functions to find the nth Fibonacci number. So here Fibonacci sequence we know 0. So if we have the number 0 and 1, the next number in the sequence will be 1. The next number in the sequence will be 2 and so on. So this is the Fibonacci sequence. Now we are going to write a program for this by using functions, that is user defined functions as well as recursive function. So here this is a function we have defined. So this is by using recursive approach and this is by using non-recursive approach. So this is the main function. So here we have declared two integer variables. One is n, the other one is result. And then we are storing the value of n by means of, so we are reading the value of n by means of scanf function. And then we are calling the function. This is the name of the function and this is the parameter we are passing. So control is transferred here, Fibonacci recursive. So this is the recursive approach we are calling. So it has a base case and the other one is recursive function. So base case, the terminating condition is whenever n value is less than or equal to 1. So it will return that n value. It will return 1. It will return 1. Else it will go on calling the same function. Suppose we pass a value 5 here. Suppose we pass a value 5 here. So n value is assigned 5. So 5 means this 5 is less than or equal to 1. This condition becomes false. So therefore this statement is executed. Else statement is executed. Again this will call Fibonacci recursive of 5 minus 1, that is 4. So here it will call 5 minus 2, that is 3. And then again it will call this function. Again it will check the condition. N value is less than or equal to 1. So if it is true, then the statement will be executed. Else it will execute this statement. So now when after this, whatever the answer you get, so that is stored in the variable result. Next approach is by using non-recursive approach. So in the non-recursive approach, so this is the function definition which we have used here. So here also we have written an if condition. If n is less than or equal to 1, return 1. So else we have used a for loop here. So this for loop, I value is starting from 2. So I is equal to 2, I less than or equal to n, and then I plus plus. So here we have taken three variables, previous, current and next value, and one more looping variable, I. So here previous value is assigned, previous variable is assigned a value 0, next is equal to, so here suppose this is the next variable, next is equal to previous plus current. So previous is 0 here, current is equal to 1. So next is equal to previous plus current. This is equal to 1 now. Now previous is equal to current. So what is the current value is 1. And then in the current value is equal to the next one, that is equal to 1. So in this way, we are going to assign these values, the corresponding values to the previous and current variable. And then finding out, we are going to find out the value of the sum. We are going to find out the next variable value with the help of this variable. So at the end it will return. So at the end of this loop, when I is less than or equal to n, so it will execute, it will come out of this for loop and then it will return the current value. So here when we execute this program, and if the user is giving a value 4, enter the value of n. If the user is giving a value of 4, then Fibonacci number at position 4 by using recursive approach is 3, and then it will display, in the next line it will display the Fibonacci number at position 4, the same value, that is 3. So this is nothing but at position 4 means 0 plus 1 is 1. So this is the first, second, third and fourth position. So in the fourth position we have 2, 3. So 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, and then 3 plus 1 is 6. So here at the fourth position we have the number 3. So that is which is displayed here on the screen. So in this way we have discussed programs on which are there in question bank based on user defined functions. In the next video lecture we will discuss some more programs based on C programming. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.